Okay, coming to you live from the Jackson Girls Playroom, teaching inverse operations, take one. We're going to start our discussion of inverse operations with looking at a function, a specific function, just one that I wrote here graphically. So first of all, before we get going, the idea of an inverse, okay, is that we're doing the opposite of a function. Not opposite in terms of like positive, negative, but opposite in terms of undoing. So you're going to hear me say that word quite a bit. We are trying to undo all of the operations that are in a function. So for example, with this function right here, if I was going to graph this, okay, if I had to do it by hand, and I know we don't do a ton of this, but I would plot points for x and then get the corresponding values of y. Now I'm going to use a couple of specific numbers. When you look at this, like I don't want to plug in the number 0. If I plug in the number 0, square root of 2, right, that's a decimal. So let's pick numbers to plug in for x that are going to give me perfect squares under here. So the first one that makes sense is negative 2. Because if I plug in negative 2, negative 2 plus 2 is 0, square root of 0 is 0, 0 minus 3 is negative 3. Next number that makes sense, how about negative 1? If I put a negative 1 here, negative 1 plus 2 is 1. Square root of 1 is 1. 1 minus 3 is negative 2. The next number that makes sense, how about 2? If I plug a 2 in here, 2 plus 2 is 4. The square root of 4 is 2. And 2 minus 3 is negative 1. And then the next number that makes sense is 7. Because 7 plus 2 is 9. The square root of 9 is 3. And 3 minus 3 is 0. So here's 4 points that I could plot. Now, I drew this freehand. This might not work out perfectly for us, but we're going to go with it anyway. So negative 2, negative 3, we'll put that right here. Negative 1, negative 2, we'll put that right here. 2 and negative 1, we'll put that right here. And 1, 2, 3, 4, 5, 6, 7, 0, we'll put that over here. So this graph of this radical function looks like that. I hope that makes sense based on what we remember about transformations. Remember what we talked about with transformations? Okay? The basic radical function starts at the origin and climbs like this, right? This rational function has been shifted to the left. Remember, whatever happens inside the function, we do the opposite, and we do it horizontally. So this, we're moving 2 units to the left. So we're moving that initial point 2 units to the left, and we're moving it 3 units down to here. So this does kind of follow the pattern that we discussed in terms of transformations as well. So this is the graph of this function. If I wanted to talk about the inverse of this function, we're going to look at this in 2 ways. One way is if we're undoing, or if we're doing the opposite of a function, I said this, maybe opposite's the wrong word. We're not going to take the opposite of every single number. What we're going to do is we're going to switch the x and the y columns. Okay? And I'm going to do that in a different color here. So if this is, let me change this real quick, sorry. Let's call this f of x. If this is f of x, we notate the inverse like this. Okay? The inverse with a little negative 1 here. The inverse of the function f, we would take all of these values and we would make these the x values and we would make these the y values. So we are switching the x and the y column. That is one way to define an inverse of a function, is we switch the domain and the range. You should write that down in your notes. I'm limited in the space that I have here. Okay? But to find the inverse of a function, we can switch the domain and range to create the inverse. Okay? So we're taking these values, making them the domain. We're taking the domain values and we're making them the range. Now if I plot these points, negative 3, negative 2, negative 2, negative 1, negative 1, positive 2, and 0, 7, I get this graph. And take a look, and what do you notice? Okay, very similar, right? If you had to describe how this graph is related to this graph, okay, I can help you out with this because you're there and I'm here. All right, but if you look at this, you're like, it's kind of like the same thing but flipped over. We can be even more specific. This inverse function has been reflected over the line y equals x. We call this the identity line. It's just a basic linear function that crosses through the origin that has a slope of 1. If you look at this, every single one of these points is a mirror reflection over the line. Again, it's drawn freehand, so it's not perfect. But this point reflects over the line. 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 So a second way to identify an inverse of a function is to say, if I reflect the function in the identity line, I get this inverse function here. So the pink is the inverse function of f. The black is the function f. Okay? So again, just to reiterate one last time, how can we find an inverse of a function? By switching the x and y columns. We take the x column for the function, we make it the y column here. We take the y column for the function, we make it the x column here. And if I graph that, I get a reflection in the line y equals x. Okay, we're going to talk about something else here in the next video.